And we're live. Okay. All right. Welcome, everybody. Tonight is the 23rd of February. We've gone from -2 in Dallas Fahrenheit to 79 today. It was beautiful 81. In the span of 7 days. Yeah. And I had to sit behind a screen all day. So, you know, what a life it is that we live. So this is the Dallas Personal Robotics Group. And we talk mainly about robots, but often about what other issues seem to be on our minds of the day. My name is Carl Ott. I'm the current president of the club. And tonight we'll follow the usual format. There's nothing really special, at least that I'm aware of. So we'll just go around the table and everyone will share what they've been working on, what challenges they might have, targets for the next week, things like that. So I'm going to, I think Murray has an update to give, hopefully. And then I'm going to bug off so you guys just shuffle around and I'll join you all in a little bit. Take it away, Murray, or whoever wants to jump in. Murray doesn't have anything tonight. I can't pick on him. Okay.
Well, I can start a little. I haven't done much, but in my case, but I did put batteries in this thing, so you'll see lights now. And I managed to figure out that little buttons will work. So sewing buttons snap onto the back here. So right now, manually, I have to do it, but when you put that there, it can move. So the next step is putting all my parts together, which is what I'm slowly doing. So I'm toying with going Raspberry, but it's been a couple of years since I played with the Raspberry, which I have. And I don't know, Chris, what type of board you were using or interface, but this one has a GOCUPI 0.4 version little board on it. So I may go with that or go with this more driver. So I'm debating which one to go with. So I may pick your all brains and say, which one should I go with type thing. So that's sort of the question.
What was that? That was a motor driver board that connects to the Raspberry Pi?
Yeah, basically. It's, I don't know how.
Let me just pin you a video so I can see it better.
Okay.
Go up.
Down. Go down.
hold it still. Hold it still. Okay, go. Okay, I see. Now I haven't come across that one. Okay.
Well, I guess a couple years old. I don't know. You know, I got it 3 or 4 years back. So
I think at the end of the day, the main thing that matters is, you know, how much current can it supply to your motors, and you know, do they give you libraries that work so that you can use it from the Pi in Python or whatever you're using, whether it's C++ or Python. So hopefully they give you all the libraries, and hopefully all that works. I mean, but other than that, I would say there's really nothing else you need to be worried about. Too many of these boards out there.
Right. Now, I saw that on a video the other night. I was surfing the web and ran across a video, and I think it was talking about this as a possible. So that's
up. Is that intended for the Pi, or that's just kind of a standalone thing?
A standalone thing.
Yeah, it looks like it wants to be fed. Okay, that looks like a standalone L298 thing.
Right.
It's going to want to be fed with the PWM signals, which the Pi is not particularly good at generating. So that's not going to be a good option for interfacing with the Pi. You want something, preferably, you know, when it comes to these motor drivers, you'd want something that connects to the Pi over I2C or SPI.
Here's another option. I have a couple, and over the years I've collected, so that's why.
That is, wow, what's on that one? That has relays on it and a bunch of other stuff.
The one you held up earlier looks, I was looking at the packaging, which is the packaging like this one, and that's OSTEP, which is the British Columbia, I think, company. And I can look up their motor driver because that's the stuff I use. I don't use that driver, but I'll see if I can find it. Does it have a name on the board at all?
When the back says What does the back says? On the front says a L29A Dow H bridge driver.
Yeah, that's fairly generic, but it definitely sounds like, if it's just a bare bones L298, then again, you're gonna need to give it the direction signals, PWM signals, and doing PWM is not something that the Pi is particularly good at.
So you're telling me the other two boards may be better based on that thought. I just haven't researched the other two that much. I got them, years back when I was thinking about Pi and the Raspberry and that. And
I mean, I have one floating around that. There's a couple things. I don't have everything on my desk here, but yeah, there's a couple ones that I have that I'm not actually using, but they're all plug into the Pi, and somebody else in this group has shown it before. Pololu makes a device that's designed to go into the Pi. It's a little daughter board for the Pi, and it has motor drivers on it, and it has its own microcontroller on it, so you can do all kinds of stuff. And it's similar to what's on the Romy robot platform that Ray and I are familiar with.
Yeah.
And it's not a super beefy motor driver. I forgot the specs, maybe an amp and a half or 1.2 amps. But for a small robot, it's enough. But my point is really, you get the libraries, you plug it into your Pi, and you get the motor drivers which you want, and you get some other, I/O as well, like a couple analog inputs and so on that you can tap into. Right. And so it's a convenient option actually.
Yeah, because the rover has, I think, 6 1.5 volts AA batteries. So it's not a lot of ampage that it needs on that for that. So that's why I was thinking, for the base, use the rover and then put the other stuff on top.
Yeah. Yeah, it looks like Ray is going to show the thing I was talking, exactly that one. Yeah.
Yeah.
Okay.
That's a really good one. That actually has a switching power supply that'll provide enough current. Used to be more than enough for the 3 plus. I'm not certain about the 4, if that's going to cover that, but very wide range of inputs. 5.5 to 36, 1.7 amps per channel for the motors. It's got a 32U4 on it. And kind of like Chris said, it's similar to that's the Romy. Come on, there it is.
Okay, I'm going to ask you another question then, because I haven't even looked at the Raspberry to see exactly what Raspberry it was until just now. So how do you tell if it's a 3, a 2, or?
Well, I could see from what you held up, if I saw that correctly, it had the BNC connector on it. You got one of the originals, man. That thing is a dinosaur by today's standards.
I told you, it was a couple years back when I got a toy playing with it and never got around to it. So
yeah, that's I think an original actually. I was trying to find one. Yeah, that's like a Raspberry Pi 0, 0.1.
No, it's a Pi 1. The 0 are the small ones, right?
Oh, that's right. Yeah. Oh, yeah, not 0. I don't mean 0. Yeah, Pi 1. Yeah.
Is it? Oh, I thought it was A.
Because
isn't that what they call it?
Yeah, you'll have to Google the different models, but it's one of the old ones. It's going to be dead slow by today's standards. I mean, it's honestly, because we also used to like performance most of the time. This is not going to be a pleasant experience working with the original Pi.
Yeah, and that one doesn't have Wi-Fi either, by the way.
I'm thinking not, because
I have one of those. It doesn't have Wi-Fi.
It's a 2-year-old dinosaur already.
No, it's about
more than 2.
2011, something like that.
Well, it says up about here, Raspberry Pi. I guess that's a copy number or something. But anyway, it says 2011.12 12.
Yeah,
I
it's
mean,
a
I would
2011.
run out of patience just waiting for that thing to boot. I mean, I know it's like.
But
So
actually,
anyway.
you can get a Raspberry Pi Zero W, which has Wi-Fi, and it's not powerful, but it's powerful enough, and you can get those for like $10 or $15. They're not expensive.
Oh,
Yeah, I mean, you're right. The Zero W is not exactly much faster than the original Pi, but because it's small, it's and because it's got the Wi-Fi, at least you're getting that. With the original Pi, you're getting none of the connectivity. So go for a Pi 4 or for a Zero W.
Okay.
This little robot's got Zero W in it. Worked just fine. And by the way, on this one, you can see that little red board on the top. That's called a PiCon Zero, and it's from Piborg or Fortronics. And that's a Raspberry Pi Zero W controller, and it'll run 2 motors with a relatively high level of current. I'm using a Piborg Thunderborg, which is actually the ones I'm using on my bigger robots, and I think that handles up to 4.5 amps surge current or something like that, with a voltage up to like 35 volts or something like that, and it provides you with a 5-volt for your Pi. So they're not cheap. They're about $35 or $40, which I guess is what the Pololu ones cost. But I've had about 3 of those, and they're pretty good actually. Thunderborg. And then Fortronics makes, if you want to go with a small, if you're going for a small robot, these little PiCon Zeros are pretty good because they have, and both the Thunderborg and these have a Python library that runs them, and it's easy to do. They're easy to control.
Yeah.
So should it be a 3 or 4, or does it matter?
Well,
a 4 takes up a lot of power, actually.
Right. It's true. It's true. But yeah, it is noticeably faster, the Pi 4. It is noticeably faster. And yes, it does take a lot of power.
So
I'm going to yes and Chris here because it's noticeably faster. It takes some more power. And I'm going to yes and on top of it, go ahead and buy the fan-based heat sink for the thing, and just from the get-go spend the $10 it is, because you have no idea how much rate limiting goes on due to heat, because that thing puts out a lot. I went from like a snail to a race car because I put that heat sink on there, and it was amazing the difference in speed I was getting. It wasn't bad before, it's way better now.
Yeah, but Harold, if you think about it, you have to balance that on whether if you're running something that's on a desktop with a plug into the wall. It's one thing on a Pi 4, but if you're running a robot and you actually care about battery life, you might be, if you don't actually plan to run video and you're not going to be running machine learning or anything like that, a Pi 3 B+ is plenty powerful. That's what I'm running. Certainly. I thought about running a Pi 4, but the power consumption is so much higher that your battery life is about half.
Yeah.
So, Tristan, what you were showing us last week, was that a 3 or a 4? I assume it was a 3 then?
Well, the one I have on my Romy robot is a 4, again, because it just boots much faster. It is faster. I only have 6 AA's on my Romy. I mean, I don't have a lot of juice on my Romy. I do find myself, changing the batteries frequently.
How often? Like every hour?
No, I mean, I don't know. I haven't timed it, because what I end up doing, right, to not drain the batteries too fast, when it's sitting on my desk and I'm just, fiddling with stuff, I have it actually plugged in, into wall power, right? With a little, I have, a little USB-C little thingy. My Romy is plugged in. And then when I put it on the floor and run around, well, then it runs off the batteries. And now again, I haven't timed it, how much runtime I get out of it. But yeah, with 6 AA's nickel metal hydride, there's only so much juice you get out of those. So I don't think the Pi 4 uses twice the amount of power. I mean, somebody must have the chart somewhere, but it is substantially more. But honestly, I would still go for the Pi 4, because you're just going to be so much happier with the performance. That's really, for me, I mean, even boot up time or anytime you do something over the network, it is just faster.
Yeah, this little fan takes 270 milliamps at 5 volts.
I didn't find it necessary to put a fan. I did end up putting the heatsink. Initially, I didn't even have that. There's a way to determine if and when and how much it's throttling. So I put the heatsink, and I found that it's still occasionally throttling, but that doesn't bother me. But I'm not sure you need to go as far as putting a fan on that thing. I mean, unless, of course, if you want 100% capability under sort of all circumstances, you might need a fan. But how often are you going to fully max it out? I mean, unless you're deliberately running some stress tests, which I only do on occasion because, I'm doing some timing stuff. I mean, you're not going to really fully exhaust the thing unless you're doing video or neural network stuff or RAWs, and all kinds of stuff with that. Most of the things we do, we're not even going to exhaust the performance of the Pi 4. So even though you don't need the performance just from a boot up time perspective, or anytime you interact with the user interface, you're just going to be so much happier with the performance of the user interface. If you just do SSH, in the terminal, then I guess, maybe it matters a little less. And the Pi 3 is good enough. I agree with Murray there. And it might be good enough for most people.
Just have your robot monitor the temperature and speed up so you get more wind going across the CPU as you're driving.
Yeah, I was gonna say.
I just looked up.
Yeah, so
telling
me is if you get your robot going fast enough and it stops, it actually just froze over. Is that what you're telling me? That's what I'm asking.
I know the Mars rover guys had to do some crazy things, tilt it towards the sun to charge it, and all these things. Yeah.
I just looked up the power consumption on the various Pis, and idle on a Pi 4 is about a half an amp, and on a Raspberry Pi 3B Plus is about a third of an amp. When running stressed out on a Pi 4, it's about 1.3 amps, and on a 3B Plus, it's about 980 milliamp. It's under an amp. So it's 20-30% more power being consumed. And like I said, if I kind of take David Anderson's thought about his, he's using those ST things and saying he's only using like 4% of the CPU. So unless you've got video or some real strong need, you're not going to max out a Pi 3B Plus either. And the boot time, I agree, Chris, is a bit faster on a 4, but I'd rather go for battery life myself. And I am actually SSHing in, and I'm not doing anything really, really heavy like machine learning. So it really depends on your need, I think. I would go for battery life on a robot any day if I didn't have the requirement for machine learning.
So in design, the part of my concept is, and why I was asking that sort of question was because, we were toying with the idea of having a robot video thing. So that's partially, which would be better for that?
Well, I can stream live video on a B3 plus, a 3B plus, but I wouldn't try to do any heavy processing of that video without a Pi 4. If you're just streaming it, it's not a problem I've done that. Actually, I had a video I put on YouTube of it streaming. It's not a problem. But if you're going to process that video on the Pi, you definitely want a 4.
Yeah.
So so based on that, the assumption then would be is that we probably would be better off having separate video from the robot then? Or could we do it through the Pi?
Well, I mean, again, what Murray is saying is if you're trying to analyze the video, right, and look, like following a line of sorts, or detecting people, right, that's what takes up really all the power you can throw at it. But if you're just streaming the video to a web client, the Pi, even the little guys, the little ones are really good at that because that's all done in hardware, and you just send it over the network. It doesn't really take much CPU time to do all that. The Pis are good at that.
So you're saying,
if you're just running streaming video, I think I can't remember the actual numbers, but as Chris said, it's all in hardware, and so I can run my robot around on a on a Bluetooth controller and drive it with video and everything on a 3B plus, and the video component of that is it's I wouldn't say trivial, but it's not really a big problem. It has no problem with that kind of video. But if you're going to process the video, if you're like going to pull the MPEG apart into JPEGs and actually look at what's going on, and let's say do line following, or let's say, or maybe camera as sensor, anything like that, as soon as you start to do that, you're going to max the Pi out like very quickly.
So in the application we're thinking of, we really would be having the human person do the processing, right? And therefore,
well,
yeah, you could get
if you're
away
going
with
to do
less.
that, actually, you might want to start looking at like one of the what do they call these things? I've got one right here. I forgot the name of it.
Just the Nano.
I haven't used it much. It's this is the Nano Xavier or whatever. You know, getting into one of the really serious processors for video, because that's the Pi 4 isn't really even hardly powerful enough to do high, you know, let's say 30 frame per second processing of video images. That's really asking a lot of even a Pi. A Pi 4, I mean.
Yeah,
but just
using the Xbox 360 Connect, a 3 couldn't handle the 2 video streams. You know, one was just a regular video image, the other one was a depth map, and it couldn't present the 2 of them at the same time, whereas the 4 can. So it's, you know, it's right on the edge of being able to handle two 640 by 480 streams. I don't know. I think that was closer to 30 hertz, not 60 hertz.
Yeah.
So.
And one of the things I've thought about doing is that almost all of, well, not almost all of the Mars rovers use stereo cameras. And if you're going to go stereo camera, you definitely need a powerful computer for that, because a Pi 4 wouldn't even really be enough for that. As soon as you get into like multiple video streams, there's a certain threshold you reach, and then you just don't have enough power.
If we could only get those plutonium batteries, I think that would be key.
Even a small one.
Small one, yeah.
Talking about power, my laptop is running out, so.
Oops.
Oh.
I'm holding out for those diamond nuclear batteries.
Wow.
They're looking at using waste nuclear fuel and diamonds or something to as the next greatest power source, solid state.
Ooh.
Apparently, the amount of nuclear material in them is extremely low, so they're safe. Don't lick them. And
the project is sponsored by De Beers, right?
And De Beers probably as well. Exactly. Up Northern Ontario or South Africa, wherever you want.
We've got the batteries for you.
Diamonds and plutonium. I mean, my God.
What could go wrong, eh?
Yeah,
exactly.
Well,
it's the last battery you buy, because they last 238,000 years or something.
It's also the last battery you buy because you die after buying it. Yeah.
So the idea behind those batteries is, as the uranium, which is, you know, deadly, or plutonium, which is deadly to us, as it decays, it sheds electrons, and those electrons interact with whatever the other substrate is, and it produces some kind of power. Is that the idea?
I believe that's it.
I mean, the thing is sound. I mean, you know, it's going to do that. Whether it's going to kill you or give you cancer, I'm not quite certain. Right?
Exactly. It's bad enough I got to worry about lippos burning the house down. Now I have to worry about
getting cancer from your flashlight.
Cancer from my hobby.
Yeah.
Yeah, leak from one of those batteries is not good.
You know, there's several other options besides just using a Pi if you want to do AI. You know, one is the one that Ray uses, which I think it's called OpenMV, and then there's the Pi Max. Those are doable, and then there's this. This is the OpenCV D. It's stereo. It's just out, and you know, hey, you know, if you're trying to grab this wave, this might be another option for you.
So which one is that, Doug?
It's called Oak D, I believe.
Say that again. Sorry.
OAK D.
Yeah.
Well, they actually call it the OpenCV AI kit.
Oh, okay.
All right. But there's 2 versions. There's one that's just a single camera, and then there's the stereo camera. Yeah. And this one I got as part of Kickstarter. So I don't know, and it, you know, they really decked it out because they made gazillion bucks on it. So they had all these match goals with things that they would add to it. But anyway, this is supported by the people who do OpenCV, and they're really starting to push it. So it's something to think about. I want to say it's around, it's over 100, but it's not, it's under 150, I think.
So it's got obviously cameras built in, but it's got a lot of processing also on board. Is that what you're saying?
It actually has 3 cameras. This one, 2 are providing depth information, and the center one I think is kind of your classic, you know, AI type camera. So
the resolution looks to be really high. Unless I'm mistaken, the 2 side cameras are 1280 by 800, and they're I think black and white, and then the center camera is 4056 by 3040. Wow.
Yeah. But anyway, they're, you know, trying to build their community over it. So, you know, you don't have to rush out and grab it. But on the other side of the coin is it looks like they're starting to be successful in it. I know they made a beautiful looking part. I mean, it's gorgeous. It's aluminum, brushed aluminum case with, huh?
The website that I saw says it's $299.
Oh, well, it wasn't that on Kickstarter.
I just posted the Kickstarter link.
I'd have been in shock if I had spent $300 on it. I was doing it to support them, pretty much. The other thing I wanted to mention, the guy with the Swiss accent, what's his name?
Andreas Spies.
Yeah. Anyway, he did a review on the 4 with this one, which is the one you notice it's got 2 little stands on it. Okay, and it works great, you know. But he also said that he was able to successfully max out, you know, like really max out the processor and not get throttled using this guy, which is the same from the same company. It just doesn't, instead of having the 2 fans, it's just a solid block of aluminum. So he's on the internet, and I think everybody probably has seen this one, at least one of his videos. You might want to go review his Pi 4 casing and which ones that you had to heat sink it. And he's done a couple with different fans too, but he was successful with this one also. And this is like I think Chris mentioned, these are about $10, you know, from your usual sources in China. So that's another on the Pi. And I guess my thought on it is I probably will go. My donkey car used a 3A, and the performance was okay. I think there were other issues besides the processor. But if I'm starting a new project, I probably would go with a 4. And I mean, I just get a bigger LiPo battery, you know, if I was worried about
more power.
Yeah.
More power.
More power, right. You know, I just wouldn't worry too much about it. I mean, because most of the time when you run your robot, you don't really run it for hours. And like Chris says, when you're doing debugging, you probably got it plugged in. Because it's just easier to use with your computer to get everything going. You know, you probably got your compiler. Well, I don't know. You guys might do it, but you know, you have these compilers now where you compile on your PC, but it has a cross compiler that throws it over to the Pi, and it's all transparent, and you don't even. It's just like you have the Pi as part of your PC. So, you know, you can use some of those things. I'm just saying that I think I would go with a 4, just because I think it's a hell of a lot faster. We know that, and it's also the way this thing goes. people aren't going to be supporting the 3 that much. Okay, so you might as well grab onto the 4.
Yeah. Although the Raspberry Pi Foundation, I mean, you have to hand it to them. You get one of their SD card images, it runs on every single version that's out there. You know, and that they've been pretty clever about it. Of course, again, you're gonna have to wait a couple minutes for the old one to boot up, like we said. But they've done a fantastic job being backwards compatible, and to some extent, that's probably quote unquote slowed down their ability to innovate a little bit and go to 64-bit and so on, right? Because they have a single image, okay, with different kernels on there. They're obviously behind the scenes some differences that are all transparent to the average user, but they've done it really well. You take the SD card, plug it into my very first Pi, it'll boot up if I wait long enough, right? And I plug it into my Pi 4 and it'll boot up about 10 times as fast. And you know, but it's just the fact that they made it a commitment to support all the generations of the Pi. You know, I think that's part of their success, really. So I don't think they're gonna discontinue support for the Pi 3 anytime soon.
No. I don't. That's not what I mean. I'm just saying is people will make their new projects. They'll design it with the capability of the 4. So that just means the things that are not 4s are going to be slower than they were. They won't be really optimized for a 3. They'll be optimized for a 4. But
that is for people who are building robots that have vision and the requirements for a 4. But like for most of my projects, I don't have any need for that. And I'm kind of, like I said, going back with what David was saying, is that he's only using a small portion of his processor. So I really kind of like the battery life. For me, that's more important.
I guess on that too, Murray, you know, if you're not like as you mentioned, if you're just using it sort of as a way to do Python, okay, if that's what you're using it for, a way to do Python to control your robot, then you can do it probably with a 0, okay? But now the thing I would argue is, though, with MicroPython so available on some of these other things like the MaxPy and stuff, you know, why not just do it on that, you know?
Well, I've considered that, and I've got actually, I'm waiting for the little part to come in the mail, but I've got the RP 2040, the little Pico, and I'm gonna probably give it a try. The issue for me, and maybe you guys can help me out on this one, is that my Python-based robot operating system that I've been writing is a single driver file, and then about, I don't know, a couple dozen library components that it calls, and then another dozen or so libraries that I install. Now, my impression on MicroPython is that in order to get that same kind of Python environment, both my driver, my libraries, and the libraries like NumPy, for example, you can't run NumPy on a MicroPython environment, and I use NumPy, and so therefore I'd have to stop using NumPy, which is the numeric library in Python. I'd have to stop using it just to go onto MicroPython. So
there's no question it's more limited. There's no question. I mean, you're right. I mean, the thing about what you're really saying is, hey, if I use a Linux computer, then I can get all the Linux libraries. You know, you might not get them all, but you get most of them for sure. But if you're running on a MicroPython, all you're really doing is allowing the guy to make his syntax, Python syntax, as opposed to C syntax, which, you know, I personally I prefer C syntax myself, but that's because I never have gotten my indentations correctly set for everything. You know, sooner or later I'll get one indentation off and I'll get, and since I can't see it, I never find it. You know, it's just like,
and the interpreter will let you know the first time you try to run it, though, if it's off by even a character.
That's true.
Yeah, Mary, you're doing pretty sophisticated things in Python, so I think you would have a hard time going to MicroPython.
Yeah, and that's probably true.
And I can probably report what I've been working on lately, which is that The architecture that I've had is which comes from my background in Java, is to have a message bus, which means that you can have, it's a publish subscribe model where you basically have your sensors publishing events, and then you have subscribers like your motor controllers and your basically that whole subsumption architecture, which is an arbitrator and a controller receiving those events and interpreting them, and then doing something based on the events it sees. And it turns out that I'm getting burned by Python a few times. Like first I thought the threading structure was good and working, and it turns out that it's multi-threading isn't what Java has. And it turns out that the message bus that I've been using, which is a library that I download, isn't actually asynchronous. It's a synchronous one, which means that all the subscribers receive a message, and until they're finished with the message in return, the rest of the subscribers don't get that message, which isn't working. So what I've been doing in the last day or so is I've been writing my own based on some examples. There's an asynchronous library it's not a library, it's asynchronous syntax. Well, no, it is a library. It's called async.io. And I'm trying to write my own asynchronous publish subscribe message bus in Python so that it will actually treat the messages. As soon as a sensor publishes a message, the subscribers receive the message in random order generally, but very fast. So none of them are actually blocking. And so that's actually what I'm working on right now, is trying to get that working. So I'm replacing my message bus with an asynchronous one. And all these little tricks, to try to do this that's part of the challenge for me, is doing this stuff. But as we've discussed in the last couple of weeks about Python on Linux, there's some, you gain a lot, but you also lose a lot. So the idea of going back to MicroPython and shedding some of the complexity and simply programming the robot differently is certainly something I think about. Like now that I've got this little Pico, the Pi Pico thing, if I can actually write a subset of my my controller, my robot controller, that's still a subsumption architecture, and David's done this in C++. It's obviously doable, but I would have to shed a lot of the things that I've been exploring and simplify things quite a lot. But that's basically what I've been working on, is trying to kind of get through some of these rather difficult Pythonish Linux kind of stuff.
Yeah,
and all that.
That can be tough.
Yeah, and Marty, make sure you give my real-time kernel a try. I really want to find out if it improves your situation with your application and the things you're doing, but I suspect it will. So
I'm unfortunately,
give it a try.
I'm all pulled apart right now because in addition to the stuff in my software, I've on both of my robots, I've got these little tiny Adafruit displays, and some system update, a sudo apt update, recently knocked both of them into blackness. So I've somehow got an incompatibility between the software libraries with those little mini Pi TFT displays and so I have no display on my robot, which doesn't keep me from doing anything, of course, but it's a feature that I kind of like, because actually I use a little keyboard like this and the display on the robot as a console, and I can actually type on the console on the robot. It's nice to be able to do that. I'm back to SSH entirely now.
So since we're talking about how to interact with the Pi, and some of us are using a Pi, so you said SSH, which I also use most of the time, maybe half the time, but I find actually VNC also more and more convenient, I have to say. Not that, it's a huge advantage to have the full-blown user interface in front of you, but what I find convenient with VNC, where at the end of the day, I might still just pop up a terminal window inside my GUI. But the advantage I find with that is, when my laptop goes to sleep or whatever, I need to reboot my laptop, my SSH session would otherwise disappear. And anything I run on the command line dies, right? So with VNC, you have the GUI running on your virtual display. You open up your terminals, you kick off your Python program from the command line like you otherwise would. I close my laptop and, next morning or whatever, next day, reconnect to my virtual GUI and everything is there. So that workflow you don't get with SSH. You know, you have to jump through a number of hoops to keep things running in the background when you kick them off in SSH, but then they are in the background, you're not interacting anymore. So it's give that some thought. I mean, it's there's obviously some overhead involved, but that's another difference I find with the Pi 4. Doing that with the Pi 4, and just because it's got a much more efficient network and Wi-Fi implementation and everything, the user interface, whether it's local on the HDMI or over the network in VNC, is much more snappier, you know, in the Pi 4. But either way, it's fine in the Pi 3 as well. And you know, again, it has some workflow benefits to it that, you know, give that some thought if that makes sense for you.
It kind of depends on what you're doing there, right? Because what's happening with the VNC is you're basically taking a screenshot and shipping that over the network, and then showing that screenshot on your local PC, wherever you're viewing that, and all the mouse clicks and all that kind of stuff are getting forwarded back to that over that VNC protocol. But as far as what you're seeing on the screen, that's just bits coming across being displayed. And SSH,
well, it's pretty efficient at doing that most of the time.
They work very, they do a lot of things like, hey, they block up your, they put your display in blocks, and if a block hasn't changed, they don't bother sending those bits. It only changes what only sends what really changes on your screen, and so that makes it efficient. The SSH is a TCP/IP connection, which as soon as that TCP/IP connection is broke, you know, when the retry interval goes out, your connection is just gone.
Yeah,
that's you know, it's just the nature of how you're connecting to the machine.
Well, I just wanted to add, Murray, what I'm doing on my robot, again, for faster boot up times, it's actually configured not to boot up into the GUI, right? So it's configured for headless operation. Then I SSH in, and then I kick off a virtual VNC session. The difference being, what makes it even faster that way and more efficient, it's not sort of screen scraping the actual, you know, frame buffer of the real display. It's just setting up a virtual frame buffer, and your GUI is drawing directly into the VNC server. So the VNC server knows immediately when something on the screen has changed. It doesn't have to keep, you know, scraping the actual physical frame buffer. So the bottom line is it just makes it a little faster. So you actually, you know, have a fully separate virtual screen basically going on that you ship over the network. And, you know, regardless of whether you have the Pi set up to put something on the physical HDMI based screen or not, which, like I said, on my robot, I don't, so that it boots faster. And then I fire up the virtual GUI, you know, when I need it. And then once it's fired up and I close my SSH session, that virtual GUI stays there. Like I said, my terminals are open, running some Python, whatever I'm doing, right? And then, you know, you reconnect to it whenever you want, even from a different machine, right? Even from, sometimes I have VNC on my cell phone. Sometimes I'm doing things where I want to check in on my cell phone. I pull up my VNC client on the cell phone, and only on the local network at home I can do that. I'm not set up to do it remotely, but I can just take a quick look at what's going on on my Pi in the GUI. If everything is still running or whatever I'm doing there, and then, you know, disconnect and then open it up again from the laptop. Right, so that workflow you just don't get with just your SSH sessions.
Well, but Chris, I don't actually have a GUI on my robot. Everything I do, like I'm programming my workflows that I'm programming on the Pi from an SSH session, and I never have any GUI at all. It's just SSH.
But I don't have a GUI either. Like I said, I just have the terminal, maybe multiple terminals open, right? I do the same thing that you do, except those terminals, those sessions don't go away when I shut down my laptop. That's really, at the end of the day, the difference.
Okay. Go ahead, David.
When you, let me just to clarify, you secure shell in with a -X and then run VNC locally, or are you connecting a VNC viewer with a -via secure shell?
I'm SSHing into. I don't do any X11 for port forward. I mean forwarding. Maybe sometimes do, but I don't find that working that well. I SSH in. I start the virtual VNC server on the Pi. Kick off the VNC server on the Pi. Then I get rid of my SSH session. Don't need it anymore. Then I fire up my VNC client on my computer and connect to the Pi from that.
Does that connect through a VIA? Does it connect through a secure shell, or are you?
No. There's no sort of tunneling needed at that point. Again, this is all just local network, and so it connects the standard VNC port, which is, I don't remember, 5201 or whatever the numbers are, or 5001. I don't remember, 5901. It's a straight TCP connection, standard VNC port, default protocol from the VNC client on my cell phone or the laptop to the VNC server on the Pi. There's nobody else in the middle or no SSH involved at that point, because once you have the VNC server running on the Pi, right, it's just ready to accept incoming connection requests.
One of the things that I've been trying to, because I am using a Pi 3B plus and I don't want to max it out, I'd rather have the processing power available to the robot. I'm trying to avoid anything that really requires like really heavy duty processing. And I think I've mentioned before that I'm using just a little game controller to actually control it. This is Bluetooth, so it's an easy connection. And the other thing is that I'm almost always within Wi-Fi distance of my my Wi-Fi router, I mean. And so if I wanted to take my robot out in the field like David does, I couldn't do it right now, but my goal is to be able to. And so to that effect, what I've got is my robot operating system is unfortunately called ROS, but I also have a ROS-D daemon. That's a Linux daemon that is in system CTL or system control. And so that runs in the background, and I've got a toggle switch on the robot. And when I flip that toggle switch, the ROS daemon starts up my ROS and runs. And then if I turn this toggle switch down, it'll actually shut it down again. So basically the idea is I could take the robot out in the field away from Wi-Fi, turn the thing on, let it boot up, and flip that toggle switch, and my OS would start up, and then I can control it with the Bluetooth. And as long as I'm within Bluetooth range, I'd be fine. And that's kind of my remote strategy. I did have one question. For I think it's about $20 a piece, you can buy LoRa modules. And I know you guys have played with that. And I thought about that, they have like a 2-kilometer range line of sight. And they're $20, and you buy 2 of them, and you've got connection between a base unit and a robot. Can anybody describe what their experience is with those?
I cannot. However, I had a friend, Jonathan, and I can put you in touch if you like, that he knows a little bit about that. And his comments were there are good LoRa modules and there are not so good LoRa modules. And the $20 one seemed like not so good, but I don't know what his definition of not so good is. So you make that kind of stuff, right?
Well, these are Adafruit. I assume they're probably reasonably good.
Pretty all right. They're probably all right. I think it was coming down to what the frequency ranges you had. There was like a 430 something megahertz versus another thing.
Yeah, there's a 433, 886, 909 something. I think in New Zealand the 900 is legal, and maybe the 433, which I think is what garage door openers use as well.
I don't know. I seem to remember the 433 one was what he was saying was not as good for doing things that we would normally do.
Well, if he's legally using 433, he's only can send something like 20 bits per every 2 seconds or something. I mean, it's it's made legally it's made for doing things like weather stations where they're just pumping very slow data to base, or for garage door openers and that sort of thing. Now, in some parts of the world, that's not the limitation, but in the United States, that's the limitation. And so that's why you can buy those modules with 433s if you're really targeted for places that are not the USA. I don't know about New Zealand, Murray, but in our area, it's 915 is the one you should be using.
Yeah, and that's as far as I can tell legal in New Zealand, and the limitation on that is I think 35. I think it's 35 decibels is the rating for power, and the one that Adafruit sells is 20, so it's certainly within range, and so it wouldn't be illegal here, and it'd be 900 and something. I can't remember what it is.
Yeah,
They had
I played around with two different manufacturers of them. One of them was based on the 32U4, and the other is the ESP32. And I found the antennas on the ESP32 units were horrible, and actually used another antenna, and it increased it by at least 5 dBi. So right off the bat, just exchanging antennas. The 32 or ESP32 modules have a small OLED display on them, and that's kind of handy if you want to see what the RSSI, the received signal strength indicator, is. And they have a very large budget. I drove all around, my property, got in between, the metal building and the house, on the other side of the metal building, underneath the solar, and it was working fine. It, didn't drop a, single byte. This one I've actually got, this is on the transmit side. I've got this monstrous joystick hooked up to it, just through that wire and that connector. And these are little 3.7 volt, 670 milliamp batteries.
I got some of those.
Yeah, probably from BG Micro.
I don't. I thought Tanner had them, but anyway.
Oh, did he? Oh, okay. Yeah, I got them from BG Micro.
Yeah.
I've abused the heck out of them, and they still charge. I don't know why, but anyway, yeah. So it I didn't. Andrew Spies, he's done. I think he drove to France from Switzerland to get up on this really tall peak to test the maximum distance that he could go, and I want to say he got like 20 kilometers out of the thing.
It's a good excuse to take a trip like that,
I guess, yeah. So you can look, and that's what's nice about the RSSI. I think this one, I want to say it has like a 155 dBm budget. So, and it was, I'll have to look, but I don't think it went below 100, even in some of the areas that I was surprised it was still receiving signal. So.
Well, I don't plan to have my robot get out of sight, so I don't really have a long range need. Just just something that I could have a base unit that's not Wi-Fi that talks to the robot within 1,000 feet would be plenty.
Yeah, yeah.
There's if you look at the autopilot programs, like Autopilot and stuff, part of their environment is a pair of radios to transmit back and forth so that you can do that. And since they have a big market because they're selling to all the people that are making drones, they're reasonably priced and they work well and they work real well. And you just plug one into your USB on your robot, and then the other one, onto your one to USB onto your laptop, and the other one I think is serial port to your robot, and they're definitely line of sight. So
David uses an XB, I think. Is that right?
Yeah, XB. No, this is an XB, but it's similar. But the other option too, don't forget, because it's again something that works real well, is the little radio controllers that they use for like RC cars.
Oh yeah.
I'm not talking about a toy now. I'm talking about the 2400 2.4 megahertz ones that I'll show you one here in a second. But if you have it, you can get them as I think as high as 12 or 16 channels. And the one I use has got 4 channels, which allows me to steer it manually if I want to, but also it allows me to dead man switch it. So and they're cheap, cheaper, I should say. So, and they're all kind of debugged. So it's something that there's another option that you can think about.
Yeah, because all I'm really planning to do is that right now I'm doing it on Bluetooth, and most of what I have done with this is just use the joysticks as you kind of described for basically taking over if the robot's going to go into something I don't want. And then I want a couple other buttons like a kill switch, but then maybe ones to turn and turn off various features. That's all I'd need. So maybe 4 or 6 channels would be plenty.
Yeah.
This is the I don't know if you can see that. That's the OLED display on the ESP32 based module. And so this one has LoRa. It's got Wi-Fi, Bluetooth. I forget how many pins is on this one.
Who makes that one?
That's TTGo.
Okay.
I don't know if you can see the TTGo on the end there.
Oh yeah, yep.
Got it from Banggood.
Yeah, this is the controller that I use, and it's
oh yeah, for car racing.
Right. Well, this one is, yeah, and like I say, they're reasonably priced. I got their own antenna.
It looks
and
like
most of the new ones use lithium batteries in the bottom, so they have good charge time, and they can be trimmed up.
The model that Ray you were holding up is called the TTGo LoRa 32.
I think so. I was gonna look on Banggood to find out which one it was, but that's where I got it.
I just found that by my first search it's the TTGo LoRa 32 with no space between LoRa and 32. So.
Okay, yeah.
It's an ESP32 device with a LoRa module and a LCD display. Yeah, looks good.
Yeah.
All right, thanks.
Yeah, and there's plenty of little tutorials to get you going. There's a lot of options. You can select what the bandwidth is. It's kind of like how redundant you want the symbols to be for transmission. So you actually use more bytes or bits rather for individual bytes, and that gets you basically more reliable data transmission into areas that are hard to receive. There's a couple of other adjustments I haven't looked at it in a while, so let's see, bandwidth, that. Don't I'd have to refresh my mind on all the different options there are for transmission, but there's I think at least 4 different things you can do. You can include CRC if you want, so the receiving end can actually try to check it that way. What's kind of neat about the OLED ones is you can do some telemetry. Back at your, if you wanted to send it back to the transmitter where supposedly, you would be, you can actually look at the little OLED and see what it's saying, It's not a huge OLED, but to me, the kind of the usefulness was initially just to see what the RSSI is and figure out, how difficult some of the areas were to receive signals, and it seemed to work fine. The furthest I went away was if I had to guess, maybe 1,200 feet, and there was still plenty of margin for receiving signals, and I was sending the X and Y from the joystick and the state of the buttons. This one only has 2 buttons, so 2 bits in 1 byte, so not a whole lot. But doing it 20 times a second, and it didn't have any issue with that. So
Well, it sounds like it'd do the job just fine. So yeah.
Yeah.
Thanks for taking a look at that one.
This is the drone type. This is what they look like. And I want to say DIY drones were the original people who made these. And now they're, you know, if you go to eBay or anything and just look up Peacock and ask for the radios that go with it, you'll see that this is the type they use. And again, they're pretty easy to use because, like I say, one is serial and the other one is USB. So.
Well, thanks, guys. That's helpful. I'm a little bit down the road since my robot's not actually moving on the floor yet.
Yeah.
So the next question I would have is regard to the camera then on the Raspberry, because I'm looking at Micro Center right now. I'm seeing something about module version 2. So what type of camera do you have, Chris, on yours or that?
I have actually, I guess, 3 different versions. Probably doesn't include the latest. I have, it says 2.1 on this one. I can't see the label on the other one. So, so I probably have a recent version, 2 of the recent versions. I also have what's called a no IR version of the Raspberry Pi camera.
Yeah, I've got those around my house actually.
I haven't tried them yet. I mean, again, sometimes we buy stuff and then don't use it, right? But I forgot what it does, right? It either filters out all the IR or doesn't. Honestly,
No,
I don't remember which
doesn't
way
have,
it is.
It doesn't have the IR filter in place like the normal cameras do.
All right, so it lets the IR in, which means you can have IR illumination LEDs. You can use it for night vision,
Yes.
right? That's what it does. Exactly.
And that's what I'm doing around my house. Actually, I've got in fact, there's a camera you can buy for the Pi that has 2 big IR LEDs on the side of it, mounted on the side of that camera, and you plug the thing in, and it's like 2 watts of infrared light, and then the camera can see out basically 10 or 15 feet.
The reason I bought the no IR, even though I hadn't used it, is someone suggested that, again, we've talked on this call before about how lighting becomes problematic anytime you try to analyze the video. And someone was saying, I was reading, well, you could use the no IR and basically create your own lighting by relying primarily on your own IR illumination. And then at least that way you have some control over you know how your camera gets exposed. Now you're gonna lose a lot of color information, or it's all gonna be washed out, whatnot. Anyway, so I think whatever the most recent camera is, that's what you'd probably want to buy if you were to buy one. I know the recent models have higher resolution. I think they have better controls. I do know over the course of time, what you can do with the Pi camera has improved. Because again, talking about controlling how it behaves to lighting changes, and I just tried that again the other day, many years ago on the original, early model Pi with early model camera and early firmware, etc. Even when I told it to not do auto white balance, it would still do it, right? And you move your camera around, and your image changes, all your your colors get messed up, and every time you do try something with color blob detection, it gets real hard when constantly the camera is trying to adjust to the lighting changes. But again, I tried that again just recently with the standard Raspberry Pi, command line utility for grabbing pictures and video. You give it all the options, turn off auto white balance, you fix all your shutter speed, you can manually control all the parameters, and it actually does it. I mean, you're not going to get a great picture, right? You look at something where it's dark, it's going to be pretty damn dark because it doesn't auto adjust for it. But the point is, right? I mean, if I do any actual image processing, and and my robot moves around, I don't want it to constantly adjust to the changing, shadows and other conditions. So my point is, the recent stuff, and I don't know if it's because it's a more recent camera model or just more recent firmware, right?
Yeah.
But either way, it works much better than it did 5-6 years ago when I tried that. So just go with the most recent Pi camera that's out there, and there are probably knockoffs out there too. I'm not sure it matters. They all use the same sensor.
I'm using the standard Pi camera on my robot, which is actually the same camera as you said in the IR one that just doesn't have the filter. And it's, if you're happy with the resolution of it, the firmware is, as Chris said, completely supportive of processing the image. And the camera's fine if you're happy with the resolution. I can't remember what it is, but they're not expensive and they're very lightweight. And
yeah,
the one I see here is $24, so that's why I'm not going.
Yeah, the one thing you might want to think about, and most of these cameras come with exactly one of these ribbon cables, and you want to think about how long of a ribbon cable do you need, because more often than not, you might find you want a shorter one than what they give you, because otherwise you got like, a foot and a half of ribbon cable floating around on your robot, and you're gonna have to like tuck it away somewhere, and that gets really awkward. So I did end up buying, a small assortment, probably 2-3 different sizes of these ribbon cables, because again, this long of a cable, I don't know what to do with. And you don't want to fold it, and you have, so give that some thought, how long of a cable you need.
I got a question. There's mostly people talking about using the official Pi Cam on Raspberry Pis. Can they not use like UVC webcams?
You can, and I just played with that recently, just for kicks. I just actually just to as a stress test more than anything else. You can, but I mean it's the Pi is a lot more efficient, I think, at using the actual native camera because it doesn't come in on USB. And again, especially if you're using a Pi 3, which is much worse at how it's doing USB, just because the hardware is different. I mean, there's just a lot more overhead involved in taking in the video from one of those cameras, but yeah, it's absolutely doable.
I think the biggest advantage of the Pi camera, the standard Pi camera, is, as Chris noted, is that there's actually a ribbon cable connector right on the Pi board. And if you use that connector, then you just go into Raspi config, turn on the camera, and you get support both in software and in hardware. It's just so easy to use.
And it's extreme. It's almost zero overhead to take that video, send it out on the network. It costs you almost nothing in terms of overhead because it's so much of it is done in hardware, or even just to put it onto the display. If you're going straight to an HDMI display, the picture literally goes straight from the camera to the screen. There's even no software in the middle, right? So there are certain things that you can do that are just really, really efficient. And that's one advantage. And
yeah, I made there's a Python based web server called Flask, which is like the most common Python web server out there. And with it, I think maybe 3 or 4 lines of code, you can have a web server. And it took me maybe a half an hour to figure out how to take the signal from the Pi camera and stream it across on a web server. It was like less than a half an hour of work. So it's just dead easy. And it's hard to argue with that. You don't spend a lot of time on USB or anything. It doesn't take up much processing power on the Pi, and you get a streamed video. It's pretty good.
The only reason I was asking about it was that in my experience, the biggest problem with cameras is the optics and the aperture control and things like that. And you have a much wider selection of things if you go to a USB cam. That's not to say that the Pi is capable of processing it. That's something I just didn't know.
Yeah. Now there's one version of the Pi camera. I think it's called the high quality version. So it has a bigger image sensor on it, I think. But I think one of the other differences is, there are different options that are associated with the optics, right? To your point there about choices, yeah, the cheap standard Pi cameras, I mean, yeah, there is not much going on at all in terms of optics, but there are models that are actually designed even for high quality, picture taking. Again, nothing I'm interested in. I just know it exists, where you get now options. You can mount lenses and whatnot.
I used for machine vision. Those are expensive cameras for work, but I mean most I use is USB. The thing for machine vision is like all those options are available. Control the shutter time, control like triggering the exposure, everything. But I mean, for hobby, I don't know what you guys think is a good choice. Is that Pi camera considered a machine vision camera? Or I don't think the webcam can do that. But, I don't know if the Pi can be considered as a machine vision capable camera.
Well, I mean, the camera is just a camera. When you say machine vision capable, what makes a camera machine vision capable?
I mean, so what I think, the cameras I use is basically it comes in without a lens. Like it's just a chip where you can put a lens on top of it, and it's black and white or grayscale, and it's I think that's about it. Like grayscale, and I can control all the shutters, the triggering of.
So you can control a lot. At least again with recent stuff, I found that you get actually functioning control over all the parameters, the shutter speed, all kinds of gain parameters. You can turn all the automatic stuff off, like white balance. It all seems to work as advertised, and it was advertised 6 years ago, but it didn't work 6 years ago, but now it seems to. So you can control a lot of parameters, and yeah, I think you need some of that for machine vision. So according to your definition, I think that makes it machine vision capable. You can control the resolution. The lower you get in resolution, the higher you can go in frame rate. I forgot the exact specs, but the recent models, they can do probably more than 90 frames per second. I think they can go as high as 120 frames per second at low resolution. Not that anybody probably needs that. I'm just saying you have control of all these parameters.
Yeah. Does it? So is there like a cheap USB based machine vision camera? Because I don't want to go to Pi just for the camera. I want to plug in the. I don't know, for my purpose. I'm plugging in the Windows computer would be good. Ray, is that a?
This is a 12 millimeter. I don't know if you call it a barrel lens, but you can get, a lot of the cameras, even for the OpenMV, like this is a very wide, like 120 degree wide angle lens. How big it is and how much it sticks out. But the back of this one actually has, it kind of looks pinkish. It actually has an IR cut filter in it. So you can get them with the cut filter and without the cut filter. And you can get them in all sorts of field of views, from telephoto to fisheye. And the 12 millimeter barrel will screw into any of the ones that that say that they're compatible with Raspberry Pi. It's got the same ribbon cable that comes off the Raspberry Pi cameras. That's what I don't like about the Raspberry Pi cameras, is you can't easily change that. I think you can get a set of lenses for it, but these are very readily available. They're cheap. They seem to be very, pretty good quality. So I don't know if you're going to go with something where if you ever want to change the field of view, or want to have the infrared, IR cut filter or not, I'd recommend these because you just screw them in, screw them out, and you're all set to go.
That's a filter with lens.
This actually has that IR cut filter in the back, and it kind of has a pinkish tint to it.
I see.
Yeah, and that just cuts out the infrared. But you can get them without it. You can also get these are called.
Yeah, I'm pretty concerned. I haven't got any camera, but I'm pretty concerned about the cost. Because the experience I have is like lens is expensive, camera is expensive. So how much?
Those lenses are quite cheap.
Okay.
Yeah, they're really cheap. These
Yeah,
are filter switches.
By the way, while we're speaking of those lenses, did I loan somebody my set of lenses?
No, not that I know of. Anyway, I've got, these are filter switches where you can actually switch in a filter, and this one actually has, see how it has that pink cast to it? That actually has the IR cut filter kind of in place right now. And the other one,
Ray, can you recommend a website for this type of camera lens purchasing?
I got all this stuff off Banggood. Any of the ones,
Banggood or AliExpress.
or AliExpress, yeah.
Okay.
But this one that looks, let's see if I can do this. It looks reflective. That one is, it's an IR pass filter. It only lets infrared through, and it works really good with the infrared lasers, the ones below like 635 or above 635. I mean, 780, 880. It only lets that light through.
Yeah.
So
Chris mentioned that there's actually a new camera. I think it was released last year called the Pi high quality camera. It's actually from Raspberry Pi itself. You're going to Pi, and that's actually a 12 megapixel camera, and it has on the actual module, it has a mount for lenses, and there's a lot of accessory lenses. That's a 12 megapixel camera, so it's way more than most people need on a Pi. But as Chris said, that's a really great camera for what I understand. I don't want to spend $50 for the camera, but $50 for the camera, and then you add accessory lenses and stuff. But that's from Raspberry Pi Foundation. It's actually, endorsed, produced by Raspberry Pi itself. So they've gone ahead and provided a really high quality camera.
Yeah, their CS mount. It's kind of a standard mount. It's I don't know how long it's been around. It seems like a long time.
Yeah, but unless you need some very specific field of view and whatnot, right? I mean, the standard Pi cameras, they do the job quite well, in my opinion. I mean, again, there's no need to spend more than $20 on a camera.
And in fact, it just occurs to me, Chris, that actually what I was doing when I was playing with the Raspberry Pi, the standard camera, is that you can set the resolution on that camera from 1920 by 1080 from HD all the way down to like as small as you want. So you can define the size of the image, and you can either get MPEG off of it or JPEG. So you get either fixed images at any frame rate that you want, or actual MPEG at a frame rate up to, I can't remember what it is, but they're really easy to use, and frankly, for the price, you really can't beat them.
Oh, there you go. $19, comes with a lens mount.
Yep.
And it'll show up on your doorstep with an Amazon drone the next day.
Yeah.
Did it just jump $40?
Interesting. So is this would have adjustable focus then?
Yeah. And you can, any of the 12 millimeter type lenses, you can even get ones that are variable focus, variable zoom. I haven't found any that are motor driven. That's kind of what I'd like, where you could have a motorized zoom. And I haven't seen any that are autofocus, like you get on higher end, DLSR cameras. So anyone's fine.
Depending on the size of how you're supporting your camera, you might also be able to get away with this once you got the camera with the mount, with the 12mm mount. You can take like an old security camera lens and use this to mount it. Okay, so I mean, it is possible to play around with the lenses quite a bit.
Yep. And 12mm seems very common. There are others. There's, I think, 8. There might even be a 12 that's a little more common, but
I don't know if I showed that.
Yeah.
Give me a second here.
C#.list remote process.
Are you seeing this? You guys seeing the C mount?
Nope.
Okay, give me a second here. I'll go. Here it is. You should see it now. This is a C mount to an M12.
Yep.
Yeah. So you can, like I say, you can get this and you can play with it.
Well, since we're talking cameras and video, it's a shame Carly's not here, but on the telepresence side of things, and those who are subscribed to the, to that particular mailing list, I just wanted to show the thing I found, which I mentioned in the mailing list, which is similar to what Murray just mentioned, how easy it is to stream video from the Pi, doing Python. So I found something that's doing that out of the box. I didn't have to create anything. And the neat thing is it's fairly low latency, again, so for any kind of interactive remote control use case, it is not a bad option. Almost as fast as that hack that I demonstrated last time. I don't know if you guys can see.
Mm-hmm.
Okay. Almost as fast as the hack that I showed last time that went from the Pi directly into the M player, application. This is going from the Pi into a web browser, which is obviously a lot more useful and desirable. And what's, the way it's happening behind the scenes, the way they keep the latency down, is they're not going through any standard sort of streaming protocol, taking the video, wrapping it into some other transport and then unwrap, so they're keeping it fairly lean and mean by going straight from what's coming out of the Pi camera over TCP in the web, in this case using WebSockets. And then the H.264 decoding is actually happening in JavaScript. Okay, so seems a bit odd, right? Because it's not taking advantage of the hardware in your laptop or your cell phone, the hardware decoding. It's doing it the hard way in JavaScript. But the modern computers, they're all pretty good at running JavaScript. So it takes a little bit of CPU in your browser. You'll see your browser being a little busy, but nonetheless, the end result is fairly low latency video coming out of the Pi, and obviously over this connection, you guys won't be able to get a good sense for it. But even when I take that out the internet and back home, which I'm doing here, and by the way, you guys can connect to this address right now if you want. You're gonna see the same video coming out of my Romy. And if you connect to this, you get the Romy control panel. And again, you won't be able to get a good sense for it, but again, the way I try it is I use the Romy control panel and see if I can actually drive it safely while looking at the slightly delayed video stream. And yeah, it's again a little slower than sort of what I showed last time, which wasn't really all that useful because it doesn't go into a web page, but it's still doable. Occasionally it lags behind a little bit. It does catch up then, and so again, it just shows that there's a lot of stuff out there that it's just ready, almost ready to use. Still requires a bit of packaging. But the building blocks are all out there for us to use. For the kind of telepresence we're talking about.
Chris, you're not actually giving this group here, the ability to drive your robot off your desk, are you?
No, you can't. You can drive. You can drive Meromi off the cliff if you want. I have my hands right here. If you okay, if you have it open, let's see. Drive the wheels if you want. I hold it.
Oh, I'm not hooked up, but is somebody hooked up?
How to drive?
You have to
mouse around on that.
If you just click on that, you have to actually move the mouse pointer on that mouse pad area.
Ah, I see.
So you have to. Okay, there you go.
Oh, okay. All
You're
right.
driving my robot. All right, I'll put it on the ground. Like, no, go.
All right, someone else drive now. I don't want to do this. This is a lot of responsibility.
It's fine, go. There are no stairs. It can't fall down any stairs. Don't worry about it.
I'll touch one.
There you go.
All right. Wow, we got it.
So again, if you're looking, all right, what you want to try is you want to pull up the video page in addition to the control panel, and then you want to try controlling it. Now again, that control panel is a little finicky. You kind of have to get a sense for it. But to get a sense for the delay, the easiest thing to do is to just click somewhere on the side. All right, now you're just going in a circle.
So, how to make it just turn, like left turn, right turn?
Yeah, you just did. You just click in the horizontal center, and then on the left side. It's
Oh, it's like the
there you go.
X
You got the hang of it. There you go. You're under my desk now.
So this is what? Low.
Ramming into your toes.
Sleep.
All right.
Nice.
So
you got it. That's cool.
Did you have the video up as well?
No, I didn't drive it, but I do see the video and the both the control panel and video here. Yeah.
And then we can.
So now it's lagging a little. I can see it's lagging a little behind on my end, but it could also be my laptop, which is struggling a little bit keeping up with the Google Meet and all this. It's not a recent model laptop, but anyway, the point is it's and I'm gonna shut this off so you guys can drive it. I shut just the motors off. So the point is, it's just there's building blocks out there. It's just a matter of integrating them into sort of the bigger puzzle. Now, the one thing that occurred to me, again, sort of remotely driving it around is one thing, but for telepresence, you probably want some Google Meet-like functionality on the robot. But of course, that's also doable, right? I mean, even Doug, the other day, he dialed in from his Raspberry Pi on Google Meet. And what's to stop us from having two separate cameras? One is used for Google Meet and maybe positioned as appropriate for that, right? And another one is, dedicated to any interactive remote control.
On a Raspberry Pi, though, I don't know if it would do it.
Yeah, you can do it.
Yeah.
I mean, we talked about the web cameras earlier. I mean, again, there's some overhead involved in dealing with USB web cameras, but you can connect one.
You could, yeah. When I tried to do some OpenCV stuff with the Xbox 360 Connect and the Meetup stuff, it just ground to a halt. It wouldn't do it.
Oh yeah, but once you get into OpenCV and actually image processing, you're gonna. I mean,
yeah,
that's a different. Yeah, that's a different use case though. I mean, I'm not sure. we haven't necessarily talked about doing actual, video processing on the Pi for telepresence, but you almost need a dedicated Pi for just doing that.
Yep. I don't know if you guys can see this. This was a like a dome security camera, and it's a stepper-driven focus, but it's a manual zoom on there, and these two little levers, you can move these around, and it just shifts. I don't know if I can see that or not, but it shifts that lens in and out. I'm assuming that's the zoom part, because I can turn it. The other part, yeah, I can turn that. But I can feel it push against this. There's a little stepper underneath that actually drives one of the rings, but the other ring is just manual. So yeah, Chris, if you wanted, zoom and focus, we'd need something like that on there. But with both motorized. Has anybody seen them where they're both motorized? I haven't. I've looked around quite a bit.
Yeah, I mean, a true pan, tilt, zoom camera secure. I mean, I used to work in security and video surveillance in particular. I did a lot of work in that area on the engineering side. I mean, yeah, there are full-fledged pan and tilt and zoom cameras that's motorized everything, right? So,
oh, okay.
But
yeah.
they get pretty expensive.
Oh, they do, yeah. This one is not pan and tilt, but it's courtesy of Makerspace.
I wanted to share something. There's a lot of interest of using Raspberry Pi with camera for ML and object detection type of stuff. There is actually a thing called Intel's neural compute stick, which is like thumb drive looking thing that you put into the Raspberry Pi USB. Yep, Harold's got that over there.
Yeah.
So about 4 years ago.
Something that looked just like that?
Yep, yes, sir, that's the one.
Mm-hmm.
So 4 years ago, I had that implemented on a Raspberry Pi 3, I believe, if not 2. And it did a pretty good job doing object detection on over 1,000 images. So I would actually have my Raspberry Pi with the standard camera with the neural stick, and I just used the trained model from the Intel, and I would walk around the room and it would identify many of the common items like keyboard, people, dog, in some cases even type of the bird, right? So you knew the difference between the duck and the geese, which I was quite impressed because those things to the computers look quite alike. So it's something I think people should consider if you want to use Raspberry Pi. And I think even with the ROS, it's very challenging trying to use Raspberry Pi 4 alone. So you might want to take the route of using NeuroStick.
My only problem with the NeuroStick, I haven't played a lot with it, but I got on there is support. Ubuntu 18 is all anything above that I can't get support on it, and that's what I'm running on my Pi 4. So I'm actually running 20.04, and I can't seem to get support to actually talk to the thing and compile stuff and all the other kind of noise. I gave it about, I don't know, 3 or 4 hours worth of try, and I put it in the box. I said I'll get back to it later. I have yet to get back to it later. I've got other things I want to bang my head in a brick wall on. And besides that thing, even though I really want to use that stick for doing exactly what you were doing.
Yeah, it is very finicky. And if you do use it, my recommendation would be to go to the forums where there's people who would answer your questions.
Yeah.
Because you're going to run into a lot of problems.
Unfortunately, the Intel stuff, when they're doing this, they do some really cool stuff. However, it's either way overdone or half-assed done. That whole middle road of things that I find is not really their forte. Either it's just awesome, or it can work if you fiddle with it enough. I want to do a little bit of both,
Right, I would agree.
Hopefully it's not going to go the way of the Intel Edison.
I'm still mad about that.
I got one of those.
I'm still mad about that.
Yeah. Oh, the other thing I forgot to say is this is a 12 millimeter lens in there. So you can get them fairly sophisticated, and you could stick that on your Raspberry Pi camera if you wanted.
Mm-hmm. Hey Ray, have you seen one of those shutters that has like a variable contrast filter using a liquid crystal? Is there anything like that out there?
Not that I know of. A while back, Adafruit had some, it was like basically the whole LCD, the little piece of glass. You could stick a voltage on it and it would,
darken
or not. And I think I did some experiments with it. They passed infrared okay, but when they're in their transparent mode, they add different coloring effects to the image. It's not like it's perfectly transparent. It almost, I don't know, it has like a grayish bluish cast to it. So
what about gimbals? I just watched your video, Murray, and I've even indoors where my floor is much smoother, right? You get a lot of little vibrations. And has anybody ever used a gimbal on a robot that has a camera on it? Because I have to say again, late last year I bought a drone, as Mav mentioned, and the gimbal on the drone. I mean, you can go crazy with that thing. The image is just dead steady, right? I mean, those things, they do magic, right? And I have no experience in photography, so I mean that's nothing new to others, I'm sure. But seeing how well the gimbal performs on a drone, I'm just amazed how well what these gimbals can do. So
is it possible that you can buy a ready-made 5-volt or 3.3-volt gimbal already?
That's what I'm asking. I don't know if anybody has experience with that or ever thought about using a gimbal.
Or maybe adopt one that came from a drone.
I'm just thinking there must be DIY drone companies out there. So it's a good idea, though. I mean, because you're right. If you're trying to do telerobotics and you're actually on the robot and it's going like this, after about 5 minutes, you start to get a bit of a headache.
Yeah. Or you turn green because you're seeing.
Yeah. Well, I mean, the question you asked, Chris, obviously from our monthly meeting, both Scott and David use pan and tilt. I mean, tilt, I guess, to take care of the horizon. All right, and they're just using the accelerometer to do that.
Yeah, but that's not the same as getting rid of the shaking, right? That you get.
Well, I think it would just be tuning the response, wouldn't it?
Well, I don't know if you can do that.
Yeah.
It would have to have a pretty fast response to be able to handle the kind of bounces that you get when you're, I mean, a slow moving servo is one thing, but I'm assuming that the gimbal mounts on a drone, first of all, it's a drone, so it's not getting like road vibrations.
It's all mechanical. That's all mechanical, that gimbal, right? That's how it responds, instantaneously.
Yeah. Well, I think you have gimbals that you hold camera to. I mean, most of the people who do YouTube videos, they have these gimbals. They walk around with these gimbals that they can do all sorts. They can run. They can jump up and down.
So I suppose it's a component you can buy. It just occurred to me literally like just now as we're talking and seeing Murray's video and my own video, right, shaking. It just occurred to me, hey, gimbal could be a useful thing on the robot that's designed to stream video, and the gimbals on the drone, they actually have a tilt mechanism, right? You can't pan it. You just pan the whole drone. But at least in my drone, the gimbal still has tilt capabilities, right?
Well, if anybody actually finds a truly mechanical, like a non-electrical electronic gimbal that would work on a drone, just put a message into the mailing list, because a truly mechanical one wouldn't take up any battery power and it would be really quite welcome, especially if it's small.
Oh, you mean one So you're just talking about one that's like using a balance. Like sort of like when they first came out with gimbals for like video cameras, like the Steady
Steadicam is what they're called.
Yeah, Steadicam. You know, it was just a weighted long arm pendulum, and so you could. I mean, even I made one of those. You know, where I could actually run through the woods, and it looked like you were straight through. You know, there was no bouncing or anything.
No Blair Witch Project.
But unfortunately, you know, it was big. You know, because you had to hold it out. So I don't know if you could get one that small without electronics. I think they can do the same thing with electronics. David, you were holding up a gimbal. How's that? Can you explain what you had there?
Is it a drone?
It's a drone?
Yeah, that was a whole drone.
Okay.
Oh, the Mavic 2. Okay, I got the Mini, by the way, David. I got the Mavic Mini.
It's an amazing thing. When I first got it, I thought, well, this is the kind of robot I've been wanting to build all these years, so I guess I quit.
Maybe I shouldn't look at this because I'll just have to give up, right?
Yeah.
Just think of all time.
I'm not going to unfold it, but these are there's a pair of those. But anyway, ignoring that part, it's got this little carrier on it to keep the thing from moving around because it's actually kind of fragile. If you look how easily it moves when it's not powered. When it is powered, it's held in place by the current flowing through the thing. But there's no mechanical, and it's exactly right. And you go screaming across the sky, and it's just level, and it can also rotate this way, so that as you're doing this, it maintains, and it just works astoundingly well. I've been stunned at how well it works. It doesn't look
anything to control it like that.
Well, you get a tilt control, right, David?
Well, all I'm doing is I'm flying yes, I can tilt it up and down.
Yeah.
But then
you can
when
look
you fly
down.
the drone, as Chris said, you pan by panning the drone, and what it does is it keeps the image level as the drone, the drone's doing this, and it works astoundingly well. It's pretty fragile though, and they give you this little plastic thing for transporting so it won't bang around.
Now you're gonna make me want one of those things.
Yeah,
they're incredibly cool. This one it's got cameras and infrared sensors built into it. Try to fly it into a building. You turn that stuff on and fly it straight toward a building, and it you don't do it. You can't hit things. Wow. And it's really cool.
Well, mine can. Mine is not as sophisticated. Mine can and has, so.
So what does that capability cost, David?
Hey, for you folks that want to get crazy on that thing, I did this a couple of years ago as a demonstration, and they gave me one of these. I've since given it away to another person that was helping me as a reward for helping me doing all those sorts of things. But what the demonstration was that we were connected up to a Mavic Air 2 on a Windows application running cognitive services, image recognition, that sort of thing, so that in the Mavic Air 2 was the lowest model that would actually hold all the programming we had to do and all the stuff that you had to go on the thing. And it was really cool. I mean, you could code the thing up to fly a pattern, and while it's flying the pattern and doing the things, and since we were doing it inside, we were hand flying it, because one of those things, if you ever seen some of those blades cut into anything at all, you don't want to. I got 150, 200 people in the room. If it gets away from anybody, it's crazy, right? Oh yeah. Dave knows all about that, right? So what we were doing, we were hand flying it, and we had lots of objects around on the ground. And of course, it was a monkey looking for bananas, what we just coded up for doing a thing. And we showed it all kinds of things. And as soon as it saw the monkey, saw the banana, because it was talking with the PC, we had the monkey yelling out banana, 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 doing the image recognition and training it and doing all that kind of stuff. And that SDK should be available now. It was available 2 years ago. I can't believe it's not available now. You probably have to sign up for a developer, and it's a Windows app doing that stuff. It's pretty cool stuff.
one's about a year old, and among the features that are built into it, you can have it hover and recognize you. And then it can either follow you or it actually can circle around you as you walk, which is pretty amazing if you think about what it's doing. I will say this, flying radio control helicopters, one of the things you learn is you never look away. And the best analogy I can use for radio control helicopters, it's like balancing a broomstick in your hand, where the feedback is visual and you're constantly, even though it looks like you're holding it still, you're actually constantly adjusting to get it to stay still. And so I have talked about learning to fly a RC helicopters like learning to play the cello. It's on that level of difficulty. But I will say, when I got this drone, that the 10 years that I spent learning all of those skills, none of those are necessary for the drone. None of them.
Yeah, that DJI folks have done a tremendous thing, and especially that Mavic Air is a tremendous piece of equipment that I can't recommend it highly enough if you want to spend the money to get. I think when I bought it, they were about $900 a pop on that, the one I got. So they're not going to be cheap, but I will guarantee you everything that David just said they do, and they're really a quality piece of equipment. Really quality.
And it's a Hasselblad camera. I mean, from top to bottom, it's just, everything's just excellent. I don't know how much it cost. This one came from work. Chris, how much was yours?
So the Mini, I bought a package for $350 at Costco. Came with some extra stuff, extra battery, which you really want. But I think the base unit with one battery, you're looking at $300 basically to get started with a Mini.
Yeah, that's not bad. That's not bad at all.
I think I've seen the one you have, David, in New Zealand for something like 1,500 New Zealand dollars, which makes it around $1,000 US.
Yeah, it sounds about right for those things. It sounds about right. I mean, even just holding the thing in your hand, you go, that's some quality. You know how you get on occasion, you're like, that's a piece of crap, because you can tell it when you pick it up. But you pick this up, and you go, oh no, that's quality. You just tell it when you pick it up. They've done a really excellent job.
So I don't know that kind of stabilization would actually be that useful on a robot. I'd like to see somebody try and report back. But you know, on the big cameras, or even the little ones now, the image stabilization that's built in there, it's done two different ways. The way Sony pioneered was actually to basically to refocus, to steer the image around on the detector. So as your hand wiggles the camera is actually correcting for that. That's actually a mechanical thing, and they did it with a like a prism that was full of liquid or something like that. Anyway, it was complicated. Newer ones, they just oversample the image, so the area that you're actually looking at is smaller than the full detector, and then they move that detector or that area around on the image, and that's all done in software. It seems like that would be very doable on a robot.
Hey, David mentioned something about flying helicopter to the drone. Do you recall, like 10 years ago, flying helicopter was all manual and it was almost impossible? And I recall gyro coming out. It made the heading easier. It would hold the position, and then the fly-bar-less technology came out, and that was a godsend.
Yes, this man knows what he's talking about.
So did you spend many sad moments looking over a barrel of broken parts at the flying part?
I had a friend who referred to, he flew helicopters with me, and he referred to the helicopter either being in its solid state or its liquid state.
I got like 8 helicopters right now, but none of them fly.
There's 3 of them on the ceiling back here. The bigger one is the T-Rex 700, which is my favorite. But it's scary. It's scary. You know, you have these carbon fiber blades. They're 90 centimeters long, and the tips of them are spinning at about 200 miles an hour. So it could easily take off your head. And what I found in my declining years is that rush of adrenaline, which at one time when I was younger was excitement, now is raw fear.
But David, that one, isn't that the model that can do inverted flight? So all kinds of crazy flying?
All three of these can do that. Basically, what it really means is that your collective pitch can go both ways around center.
Yeah.
So you can lift or you can flip upside down. And
I've seen some guys do ridiculous things with that T-Rex where it's just going back and forth like this. And I just don't understand how it works, but
throwing it around is what they call it.
Well,
but it stays in the air when he does it. It's crazy.
So every time I flip the helicopter over, that's not in a simulator, my brain just freezes up. Like
no
upside
doubt.
down orientation flip.
Kevin, one of my friends told me that the way to learn to fly that is you get your simulator and then you put a coffee can there, and every time you crash it, you put $1 in the coffee can. When you've gotten to the point that you're not crashing anymore, you can now buy a helicopter.
Yeah.
Yeah, that's about right.
For several $1,000s.
Yes. That one come with a steel bar to, self-defense mechanism that you, in case your robot gets out of control.
Well, I have to say, when I first saw people flying their drones, after many, many years of flying helicopters, my first thought was, why are you doing this so dangerously? You're flying close to crowds. You're, all these things that we're taught not to do, because they have so much faith. But, things still break. Little crevices break, and things can go wrong, and can go wrong at a terrible time.
Well, they even go wrong on, what is it, 777 or whatever, that plane flying over Colorado?
Yeah. Lost an engine. Yeah, I wonder if that was Jack, because I thought Jack's dad flew to Hawaii. And he used to fly, he used to fly the 777 Maxes. So I don't know if he was the pilot for the day or somebody else.
I thought Jack's dad was a 737 Max, but
I thought he was a 777, but
it was a 777 that dropped. But he flew the 737 Max because he was grounded when it Pat is grounded when they had the grounding issue for the 737 Maxes.
So it depends on which one you'd rather have parts falling off of.
Yeah.
Yeah. Wasn't it the 777 Max though that had the issue?
Nope.
No? Oh.
37.
Okay.
It was a 737 Max. It's like they got a whole bunch of corners, and they got basically caught on it. People died, as I understand what all happened. There was a bunch of stuff that happened, but
they kept putting bigger and bigger motors on the thing until the airframe was unbalanced, and they tried to fix that in software. But I don't think anybody here has ever run into that problem.
Yeah, never.
Yeah.
And they had redundant systems, but both their redundant systems didn't agree. You need 3 things to vote, not 2 things to vote. And, that's one of the things I heard in their software and some of their avionics.
Well,
buried menus.
One of the things I heard was they were just reading one of the sensors.
Maybe so. There was maybe a bug, so they're just reading one of them and they just didn't even bother about the other one. Maybe so.
But the problem, I think, really was that's an angle of attack sensor. And so it's trying to warn you you're getting outside the safe envelope of the airplane. But the reason the envelope of the airplane was so narrow is because they put these huge engines on it. It was a combination of errors.
Hey, so I jumped back in and I heard talk of stabilized gimbals for cameras. Did you guys talk about the ones you can hold in your hand for phones?
I just saw those on Amazon just while we were talking. I mean, they're as cheap as $70, I guess, half a pound or something, right? I mean, I guess it is an option. I don't know how they work. I've never used one personally, but now that you mentioned it,
So as it turns out, the last job I did at TI was to do the EE work for a stabilized head mirror on a tank, basically, a light armored vehicle. So I have an affinity for these and laser rangefinders and things, but this is a Kickstarter that I've bought into now, so we'll see if they deliver on time or not. But it's kind of cool. It's a 3-axis stabilized thing. It's tuned to handle things in the weight and mass of a typical distribution of a typical smartphone these days. So this one is out there. DJI actually has several like that. They're a little more expensive, but they've been around for a while. And it's kind of cool. You can just mount your phone on it. And some of these things, they actually have these built-in little modes. Let's see what the video shows. Come on, mouse, respond to me. Where's the campaign video? Let's see. Campaign. And then I have another thing to show too. Here we go. But you can put it in these funky modes. Okay. Yeah, it'll do the twirl thing. Right. Built-in stand. So you can start doing your twerking in your TikTok videos, guys. Get ready for it. But DJI has them. And now, but so I'm actually going to get one of these as soon as it delivers. I've put into it. Well, if they deliver, I've not had good luck lately with Kickstarter.
I think Ray would probably go viral with the twerking TikTok video, man. I'm saying.
You know,
just saying.
We'll get some of John's robots. They tend to twerk a lot. He likes that way. But then there's actually one of the startups. One of the first things in my startup career that failed was well, what I did didn't fail, but the startup did. But this guy wanted to make a custom gimbal for a drone, a larger drone, and he found this this company that makes basically these are little microcontrollers that are purpose built for making your own custom stabilized gimbals. And you know, you can see they come with different kinds of interfaces and IMUs and drivers, but I was really impressed, and this was already 6 or 8 years ago, and it was really well made, and it was easy to tune up. But what you do is you get one of these cards, and then you get these are brushless motors, so these cards can drive the brushless motors directly. And the PID loops and electronics are already tied into the IMUs, so you just adapt it for the weight that you have. You have to make sure your gimbal is mechanically balanced, but why don't you take care of that? And then these are gimbal motors, and I think unlike what I understand of the kinds of brushless motors you'll find on RC cars, these things have a lot more poles. You can see a lot of different magnets and poles going around here. And whenever you start to have a lot more poles like that, you can wind up getting remarkably fine control over position on the thing.
Yeah, I think
so
they're
they
more
use that
torquer motors.
Yeah.
Torque
So you
motors.
get. So I think these have always intrigued me for a way that on the robots, if we would use these instead of the standard kinds of brushless motors that you have on RC cars, which are meant for speed, these are meant for torque, I think, and low speed control.
Yep.
So I think it'd be very interesting to combine some of these with encoders. I mean, you wouldn't have the gear ratio effect like you do on the motors typically on a club robots, but anyhow, it strikes me as an interesting option. They do tend to get pretty expensive, but you can get them in all kinds of crazy sizes.
Carl, would that be kind of, I mean, I've been kind of investigating the steering motor, like on a rocker bogie arrangement. And could you use those for steering or a stepper?
You probably could, yeah.
Yeah.
It's powerful enough.
I would think so.
Because there's a couple companies that make like the servo mounts and stuff like that, with already have all the mounting in there, and it's stainless or aluminum and everything, but they don't have the kind of, they're a servo, so I guess they got the kind of control you get on a servo.
But these are beefy. You know, they're meant for fastening mechanisms like this, and they can slew around full-size DSLRs with big lenses. I mean, these are the kind of motors you're going to find on those like $8,000 and $10,000 drones that hoist the big cameras up. And you can see how they're constructed, right? They got, unlike servo horns, they got some serious ball-bearing mechanisms and mount points. So you can put some weight on them, and they're not going to have much slop axially or
wow, I like that. That's very cool.
That looks like a lot of those motors that Bruton guy uses a lot.
Yeah, I don't know.
Yeah, he likes to throw things around a lot, and for gearing he uses a belt system. So belt and pulley. So you got a small gear and a large gear going around it, and that's how he controls his gearing.
Yeah, but you can see you can get them in all kinds of different sizes. I mean,
wow.
Well, I guess that's for drones, so tiny ones. But I was thinking for gimbals. So
that last one you showed was from, what was it called? A flash something?
This one?
No, the one before that, the little bigger one. That one, Flash Hobby GBM 2606. Flash Hobby.
They come in all kinds of sizes. So here, I'll put the link in the Slack.
Oh,
just just search for brushless gimbal motors.
I don't know if this applies here, but normally those brushless motors, the controller needs to know how many poles there are. You were talking about the number of poles in the motor, and the more poles you have, the more torque you have at low speed. And typically, at least the ones I've worked with, they're specified in terms of volts per RPM. That's what that KV number on the end there means. So if it says 500 kVn, that means 1 volt is 500 RPM, and 2 volts would be 1,000, 3 volts would be 1,500, and such. And the way those work, my understanding is that if you feed in 1 volt and expect it to go 500 RPM, that the controller will feed it the current necessary to maintain that speed, basically on its own. So as you increase torque, if you grab a hold of the output shaft, it will give you more current in order to maintain the same speed. Well, doesn't that seem like what we need in our robot?
I think so, yeah. I mean, so it's been on my list to give this a try, right? Because interesting things to play with. And we don't seem to have tried that in the club, so.
Well, what would be really useful would be for you to buy a whole bunch of different ones and then buy some expensive controllers and run a bunch of tests and report back to the rest of us on what you've learned.
That would be awesome, wouldn't it? Yeah.
Yeah, that would be awesome. It would be awesome.
I can see where this is going. I want to stop presenting now.
Kareem, haven't you played with Rev Robotics? They have a 3-phase brushless motor, right?
Yes, I have played with their brushless motor. It's designed for high-speed applications more than anything.
Right. Yeah, it's not a torquing motor, but I'm assuming the torque motors just have more phases, and it's almost like a stepper. You energize certain phases to get at certain percentages, probably DC levels to get the thing to point or rotate in a certain direction. But yeah, I don't know how many phases they have.
Anyhow, that's all I got for this week.
Cool. So is that a feature that the telepresence robot is going to have then? Gimbal and
I don't know. It's just because things get shaky when anytime you move the thing with the video, right? I mean, it's even on a smooth floor, things are shaky, and even the Raspberry Pi camera / firmware supposedly has video stabilization. I'm not sure I've noticed much of a difference when you turn that on or off. I don't know if anybody else has tried that and experienced that to work, but the built-in digital stabilization, I don't know. I didn't see a difference.
But that's the thing, right? It's hard to beat optical or mechanical stabilization. If you can get it to work well, you don't have to compromise on resolution. And there still seems to be some, like on the drone, the one I did for the drone, there's some kind of beating, and you can even see it with smartphones sometimes, that like the loops are tuned for a certain kind of motion. So like you got to have low passes to cut off the motor noise, or that can couple in and screw up the stave. Or like on one of my camcorders, if you turned on the optical stabilization, it worked good on your hand, but as soon as you put it on a tripod, then it would hunt around, whereas it wouldn't hunt around in your hand. So there's some funny stuff going on. You just got to experiment with, as the technical term goes.
The stabilization on these things works remarkably well. That's a GoPro.
Yeah.
And I don't know of anybody who's used one of these on a robot, but boy, it sure does a lot of the work for you.
Is it optical or electric or digital?
I don't know. I just know that I can run up and down the stairs with it, and it's just smooth as a baby's butt. You know, it really works great.
Because that's the crazy part to me, is that they get these smartphone cameras and they might have, and like some of them actually have optical stabilization built in. So they'll have some element that couples the IMU and it just shifts the lens around a little bit to compensate. Unlike the one I did that we worked on at TI, it was a 20-inch by 10-inch slab of beryllium, which is a toxic metal, and to put a mirrored finish on it, they diamond turned it for a few weeks, and that was the mirror. And they used beryllium because it was light and stiff, and it was a 2-axis gimbal, and that was exciting. With the 68030, David, you'd be proud.
Your tax dollars at work.
Running Ada, yes. Yeah. But I will say this, after they replaced the gyroscope, the first gyroscope had a piezo sensor, I think. And if you can imagine what happens with a tank, it has metal treads, right? So what happens to vibrations and resonances in this metal system when you drive it down a rocky road in Afghanistan at 30 miles an hour? There might be some vibrations and harmonics floating through. But what happens when those couple through all the mechanical structure, metal structure, into a piezo gyro? Out of band noise. So they would notice that in the test stand, when they put this thing on and shot the Gatling gun off to the side, the gyro would drift, and it would drift because the mechanical noise, microphonics, was coupling through the chassis of the tank and throwing offsets into the piezo gyroscope. So after that, and I didn't select it, but after I left the company, they finally had a smart guy come in and replace the piezo gyroscope with a spinning one, and then they could shoot the Gatling gun. And I mean, it's remarkable. I saw some videos at some point. You know, here's this, you imagine this tank driving down the rocky road, 30 miles an hour, guns off to the side. It's a big gun, so when it fires, it's like, right, the whole body of the tank is rocking to the side because the gun is shooting off and it's like the image for the infrared camera was on a tripod. It's just amazing. Wow. Cool stuff.
So Chris, when you were describing doing that with the Pi and the Pi Cam, you said that was a function they had built in. What were they using for the sensor? Do they have an IMU feeding back?
No, nothing like that. It's just, there is some digital image stabilization that I don't know if it's the GPU firmware doing it on the raw image, which I think what the way it works. I mean, there's no sensors, just, you know, sensing small. I think the idea is to filter out small vibrations.
It's like optical flow, right? It'll be optical flow, but applying the control loop to the center of the image. So it
right. Again, I haven't seen, not that I have done an extensive test on it. I just didn't notice any obvious difference for my use cases.
We did a project, this was about 20 years ago, where we had high-speed film of some very large explosions. And, of course, the shockwave knocks the camera around. And so what we did was, by hand, you go in and you pick out fiducial reference points and you scoot the frames around until those points all line up by hand. So the outline of the frame moves around, but the objects within the frame are steady. But that was before we had any kind of sensors that could tell us what the image was actually doing. We're just responding to it's post-processing. It's not happening in real time. But once we got more expensive lenses that did all that for us, then we just forgot about it. It's not something you have to think about.
The spy camera web page. I mean, I guess one thing is it's 2-page and it's difficult to control, but looks like it's the code is all in there. Maybe I can quickly show you something, but we can talk on Thursday. I just want to share some quick.
Yeah, I mean, I haven't integrated that with the actual Romy control panel. That would be the obvious next step. But yeah, I mean, and I can send out the link to the GitHub repo, and I put that in the telepresence email. Yeah, this is just stuff I grabbed from GitHub. And all I changed is the default resolution because it was trying to send higher res video, and then the lag gets a little bigger. And so, yeah, I mean, it's a little bit of Python code and a little bit of JavaScript.
Yeah, I'm saying maybe someone understands this, but basically, if there's a button and then there's some dragging here, and what I see is this drag. It's like mouse move. It's calling this drag. I don't know. Can you guys see this? And basically,
okay. Now you're looking. You're looking at the Romy control panel code now. Okay, and now that is straightforward. Yeah, I mean, this is the mouse. Well, the pad where you put your finger on. If you're in the center, you're basically going 0 speed on either wheel. If you're in the center and then you drag your finger to the left, you basically start turning in place, in one direction versus the other direction. Yeah, so this is what you're looking at is the JavaScript code for that Pololu remote control panel.
Yeah, so I wonder, can we make it like 1 page and replace this with like a few buttons, forward, left, right, back. So yeah, just a thought. So we can basically, we don't need to do much, just call whatever they already.
Yeah, I mean,
they're already here.
For someone who is familiar with web technologies, and I'm not terribly, but someone who knows JavaScript inside and out, I mean, you can do a lot of things real quick, between that one piece of code that did the video and the Pololu piece of code that does the remote control. You put those two together, if you kind of know what you're doing in JavaScript and Python, you have a basic, your basic
the video one,
quote unquote telepresence going, except it's all one way and there's no audio. But yeah, you have a remote controlled robot that you can control over the internet if you expose it that way. I mean, like I said, I mean, it's just proof that all the basic building blocks are there, ready to be integrated and glued together in whatever fashion is necessary.
Cool. Yeah. So we might just borrow this, and we have a UI. That's what I'm thinking. Yeah. Thanks.
Well, it occurs to me, John, that also the video class that I wrote for my robot isn't actually online right now, because during the process of upgrading and writing, I've actually accidentally deleted it because I'm not using it. But I'll go ahead and repost it. But there's a video class that does all this as well, that basically I tweaked. I wanted to basically reduce the size of the image. So I think I was actually in the end using a 64 by 64 pixel image, something like that. So I'll go ahead and into the mailing list. Once I repost it, I'll mention it. So
cool.
See you, Chris. But I'll post that into the mailing list with a link to the actual video class, and you can take a look at that as well.
Yeah, this is probably, I mean, if someone knows about Java or no, actually, I think it's JavaScript. But yeah, someone who knows? It looks straightforward. I mean, we're basically calling whatever they have, right? So like a web page with these video player and some buttons, and I mean, so hopefully Thursday or sometime we can talk about this telepresencing.
Yeah, did you guys pick a time yet for that, or?
I heard last week was like this Thursday, right? But I don't know what time.
Oh,
we should.
I threw that out as an idea, and I just heard that Doug couldn't make it. He could have made it last Thursday, but not this Thursday. But I can make it this Thursday if you like.
I mean, pick a time. I'm fine Thursday.
You're good. Is anyone else on the call interested in that one?
Is there another mailing list for that?
There is a tele_API thing that Doug is managing. It's tele_API. We can ask Doug to get you on it, basically. I forget what it is exactly. Here. This is the list for that. The telepresence API discussion.
Totally unrelated. Has anybody gotten their second COVID shot yet? Have you? Yeah, I got mine yesterday.
Do you feel anything?
A little achy today, but not too bad.
Oh, you're lucky.
How's your arm?
Hopefully nobody's going to punch me in the arm anytime soon. It feels okay. I wanted a balanced approach, so the first shot I got on my left arm, the second one I got on my right arm. Figure it would cover my whole body.
I did read that that one of the things your immune system does is the initial infection came in through that arm, so even after it's defeated the initial infection, it leaves a few soldiers hanging around that location just in case.
Oh, really?
Yeah, it's sort of like if you had a cut and then there was an infection associated with the cut, even though they've wiped out the infection, they'll still hang around. This is a likely place to find another invasion.
Yeah.
I think that's why your arm is so much sorer after the second one. So you probably did it right.
Oh. Yeah, it was actually a couple, I think they said 3 weeks for Pfizer, and it was, the week that we had all the snow accumulation, and you couldn't go anywhere and get a shot. They were closing the centers down and stuff, so they pushed it to yesterday, so from last Thursday, so a few days longer. But
did you ask if you can use like different arm for the second shot?
Oh yeah, I told them I wanted the other one. So.
Okay.
So I'm confused. So David, are you recommending that based on this theory, it's good to use opposing arms or go for the same site and the same arm?
Well, I was being agnostic about that. I was just saying I think the reason that it hurts so much for the second shot, so much more than the first, the next day or two, is because your body was primed to expect an infection in that arm.
Huh. Okay.
Yeah, I would go if I get that vaccine. Well, maybe by summer I will go with the same arm. Let it be primed and receive that second shot.
My wife was a little under the weather after the second shot, but my mother and I, she's 94. We all three got them at the same time, and she and I just had sore arms. We didn't have any other, and it just lasted for a couple of days.
Yeah, well, that's good.
Yesterday, I don't know if you guys tried this double masking yet, but I find it's very good. It's better than single.
You got it or not?
Where you could do it when my wife does and use 3 of them.
I had this N95 for construction with the valve. So I thought it's not fair that I wear that out with the valve. But now with the second mask, yeah, it makes it's good because it's got some space and it's got I'm not poisoning air without filtering too.
Yep.
So it worked out well.
Yeah, I'll be glad when we don't have to wear masks anymore. That's for sure.
Yeah, I heard it's like every winter should be expecting mask wearing. I mean that's my understanding, right? It's gonna be here.
Probably not going away soon. Yeah, with all the variants, UK and South African. I think I haven't heard much about the Brazilian one. Maybe that was a minor mutation or something. But yeah, it seems like you don't want to get the African for sure. I think that's supposed to be the most deadly. So
yeah, the biggest trouble for the current vaccine, but more deadly. Wow, it's bad.
Yep. Well, that's good. Carl, are you in the 1B group?
I haven't looked to see where I am yet. I figure I'm healthy enough and not quite old enough that I haven't looked yet, but I need to look now that I'm back in town.
Yeah.
I got my parents on queue back in Pittsburgh, so they got Pfizer 1, and next Monday they'll get Pfizer 2. And my wife's in the medical industry, so she's got both already. But and my colleagues got the first one, and they were able to do it because the body mass index was a little high, I guess.
Mm-hmm.
But the only others I know in the family that didn't have an excuse for it like that. I got one of my wife's cousins volunteered at the Mega Center at the Texas Motor Speedway. So they went and worked like crazy for a full day, and then they had to wait for 2 hours to get their first shot. And they might have to do that again to get the second one, but that was one way they could kind of jump to the line ahead of their normal physical condition.
So did they have a website to sign up for that volunteering, or did they?
Yeah, somewhere. If you want, it's in my text message thread somewhere.
Yes, like you will probably be right now. I'm thinking summertime because
Carl, one of my colleagues' wife works at a hospital, and so she was in line early, and when she got it, her husband got it too, just because they said it doesn't make any sense to send you home to an unvaccinated husband. So he kind of, lucked out, I guess. And that was
a
few months ago. So couldn't you do that too?
No. She tried.
That's a simple, straightforward answer.
She tried. Yep. No luck.
Yeah, I don't know, Carl, if you heard there were 2 younger women that dressed up as old ladies.
I saw that. Made the news.
You did, yeah.
Yeah.
Wow.
There's those techniques or approaches. Some of them don't work, obviously, but.
I figure if I just hang around and keep my head in the sand, or don't go anywhere and talk to anybody, it shouldn't be an issue. So.
Yeah.
Yeah, if working from home should be low risk, but I think everyone can sign up. So I just went and signed up. One of my colleagues saying, some medical worker said everyone should be signing up for the planning purpose.
Yeah.
So
yeah.
So I just expressed my intention or my interest in getting a vaccine.
And the truth is that in a group like this, we're all real used to being off and working by ourselves. Robot builders do that all the time. As a matter of fact, have you guys ever been to a BEST competition? The one started by Dean Kamen?
Nope.
No.
It's a bizarre event. It's a robot competition, but they have cheerleaders and stuff. And it's very, very surreal. You should go to one just to experience it. And my feeling at that time when I went was, well, Dean Kamen himself, a multi-billionaire genius inventor, was a nerd in high school. And so he's trying to give something to all these other nerds that they never got, which is like cute cheerleaders cheering for them while they do their nerdy things.
Wow,
but my thought at the time was, it's not going to work, because if you really want to go into science, you're going to spend the rest of your life in a laboratory by yourself. There's not going to be any cheerleaders. If that's what you need, you're in the wrong profession. But I just thought it quite odd. If you ever get a chance to go to one of them, they usually hold them in a big coliseum, and there's loud music and flashing lights. It's like a disco, and there's these cheerleaders. It's just bizarre. And then these nerdy little robot teams.
But that's sort of like what I deal with at work all the time. I've got cheerleaders.
Yeah, wow.
What are you doing wrong, David? I got cheerleaders, man.
People two different things.
The closest I ever came to that was I went to work for a company back in the 80s, and it was all women. There were 4 guys and 75 women. And I can talk at length about culturally what a different business that was to work at, but I sum it all up by saying it's the only business I ever worked at that when we went off on a trip, when we came back, we got hugs.
Not bad. I guess it depends on who you're getting the hugs from. If they're fat and ugly, it's kind of like, ooh,
Well, it was run by this real brilliant woman, and she went around and found all these other brilliant women who effectively had hit the glass ceiling, and brought them in and made them vice presidents and that sort of thing. And they worked their butts off for her. It was really an amazing thing to watch.
Mm. That's something. So did you get hit on a lot, Dave, when you were there?
I unfortunately did not. But Portia sat down with us one time, and she said, the 4 guys, and she said, you guys are an oddity in the business world, and here's the reason. If Adam down the hallway is not happy with what he's doing, I offer him more money, and then he's happy. But you guys will actually take less money to work on something you're interested in, which is something I can't control. And that makes you weird and definitely the most difficult part of this business to deal with.
Well, when I was with TI, I remember going to the cafeteria one time, chatting with another engineer. I'm a dyed-in-the-wool engineer, and saying, isn't it great they're paying us all this good money for doing the stuff we love to do?
Yeah, that's the weird part. It's nice when it happens. It doesn't happen all the time. So David,
you really get your money's worth when it does, because you have people that'll go home, lay in bed at night, trying to solve those problems.
Oh yeah, yeah. That's
actually, I have a what I call a guy in the back room that works on it for me, and he'll wake me up in the middle of the night with the answer.
I have heard about your guy in the back room. He's talked to me before.
So David, your experience at this company sounds like the one class I took. I took in college. It was an elective. I was interested in psychology stuff, so I found this course, Psychology of Women, and I went to this course, and it was really a kind of I wasn't expecting this. Maybe I should have expected this, but there was 53 students in there, and 3 of us were male. Apparently, it was easy for the males to get an A because nobody could relate to what we had to say. We didn't. I mean,
well, I can tell you one oddity that I noticed. I was there for 3 years, and the company grew enormously in those 3 years. There was among the people I worked with, which were predominantly women, there was this ritual of gift giving that went on all the time. So let's say 4 of them have agreed to go out to lunch, but when lunchtime comes, one of them has to stay there and work. So the other 3 go out to lunch and come back with a little stuffed animal and give it to the one that couldn't go. And this then gets reciprocated. There's this constant gift giving that went on. Now, I know I've worked at a number of companies. I know every company has a different personality, so it's not necessarily fair to blame the personality of the company on the fact that it was all women. But I thought that was a peculiarly female kind of social structure. Another one along the same lines was that there was a competition among the sales women to see who could sell the most. And there was a big cowbell that they could ring if they sold more than $10,000. And some mornings that cowbell would run all morning long, just continuously. And it was like they were giddy. And it was like being in a room full of cheerleaders or something. It was very, very unusual, high energy environment. I'm not complaining. It paid my salary, you know. But I found that sort of an unusual. And then I say the third thing was that a lot of the lines of communication were indirect, which took me a while to become accustomed to. So somebody might come up to me and say, you know, Evelyn was a little perturbed at you at that meeting this morning when you brought up that topic and you hadn't told her about it. Well, why isn't Evelyn telling me this? You see what I mean? Well, you tell Evelyn.
You should have been more sensitive, David.
She was going to flog you in the men's room or something.
Yeah. It just took me a while. They didn't really like that kind of confrontation. But as I say, that might have just been that particular company rather than the fact that they were all women.
Well, on the other hand, you have to recognize that male or female, there's certainly people that just are not comfortable with confrontation of any kind. And I think it's probably more prevalent among women. And so that I know people who, if I have an issue with them, I have to be very, very careful in the tone of language, not raising my voice, all those things. And I just have to neutralize the amount of emotion in dealing with the issue. Whereas, like the guy that I work with right now, he and I get into these back and forth, blah, 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 blah. And last time we did, as I walked away from him, another guy that was listening to us said something like, what was it? He said, oh, did you guys have a real fracas? Or, he thought we'd had a fight. I was like, fight? Were we fighting? I didn't even notice. We weren't fighting. We really like each other. We like working together, but the tone of voice was being interpreted as being angry. And we were excited to fight more ideas.
Yeah, I think that's exactly the point. And, I had come from the sort of rough and tumble startup company where the closest equivalent would be, Anderson, get over here. I got a bone to pick with you. You do that again, you and I are going to go round and round. Oh, I'm sorry. I thought we had talked about it. I hadn't heard a word about it before you brought it up in the meeting. I don't do that again. I'm sorry. I won't do it again. Now it's over. Pulled out the thorn. It's over. Well, so I was just more used to that, and I wasn't particularly intimidated by it. But and as you say, that could have nothing to do with the fact that it was a company of women. It could have had much more to do with the personalities of the people involved.
Yeah. TI used to have what they called public KITA, which stood for public kick in the ass. So I don't know, David, you ever heard of that? Dave Eckley?
I think I've experienced.
No, I hadn't heard of that. But a friend of mine and I that worked there, we would have heated arguments, and the guys in the next cubicle would say, well, we thought one of you guys would come flying out of there with somebody. Yeah, exactly. But, we'd have the heated arguments and we'd settle it and go on and have coffee with each other.
Yeah.
The man I first worked for at SMU, Roger Phillips, who's since passed away, he's one of the NASA scientists. And Roger would say, we need to look at this. So I'd go away and make some plans. I'd come back and I'd say, okay, here's what we need to do. And we need to buy this and we need to buy that. We need about $5,000. And he would argue with me, tell me why I was wrong. And I would go away real disappointed. I don't know how to do this. And then I'd run into him like a day or two later walking through the hallway, and he'd say, well, I was looking at the books and I think that $5,000, I think we can probably do that. he just wanted to see how well I would defend it.
Yeah.
You know, but I thought he was saying no. You know.
Well, I don't know. Have any of you guys ever traveled to India? But if you go into a shop in the Middle East or in India and you buy something for the stated price, they think you're an idiot because that's just not the way things are done. So you haggle, and that's what they expect. And so, like I said, I think these things are to some degree cultural, and we probably all recognize that in a heterogeneous gender environment where you've got lots of men and lots of women, it's one of these things where there's kind of a neutralization of the boundaries of those. But if you're in a very male or very female environment, then the native culture of that environment is prevalent. So if you're surrounded by women, it's kind of a women's environment, and they have their own culture that's different from a male culture. And
although I will say, I have two sisters, and neither one of them are like that.
Well, I'm trying to generalize here because if like my mom is from a family of I think it was 6 girls and 4 boys. And of course the boys they're all farm kids and they're all out in the farm. So the boys are out in the farm and the women were hanging around with each other all day. And if you listen to them now and they're all like in their 80s, you listen to them all jabber back and forth and they have their own sister culture, man. And you can't get into the middle of that. They argue with each other and fight with each other, but don't open your mouth. They'll slap you, Anyway.
Yeah, I had a story about my first wife. She was a psychiatric nurse. And I think it was a convention that she went to in Boston. And she had amblyopia in one of her eyes. And she couldn't really see that well out of it. And it's, middle of the day, bright sunlight. She's sticks her coat on and her glasses on and gets into the elevator. And the people in the elevator are looking at her very, like she's very strange, And so one of them asked, are you here for the psych convention? And she said, yeah, I am. Are you? So I guess they had a little conversation. Everybody left, and she walks out of the elevator and goes down the hall a little bit, passes a mirror, and sees that one of the lenses, or the lens that with the the eye that she couldn't see out of that well was missing. So it's like psych nurses and I don't know. So, but she said I was so embarrassed after I realized that. So, but she thought it was really funny too. So
that's good.
Anyway.
All right, gentlemen. So where are we? Are we going to talk about building robotic people now, or no? Just we're not going to try and put to an algorithm all the behaviors we've just described, right? We're going to leave those behaviors to later.
Yeah.
When we have groups of robots that have their own little culture, right?
Yeah, the gimbal stabilization. I mean, yeah, there are some. The floors in the makerspace, they were done by volunteers, and I noticed, like in the one room that we were in, somebody didn't quite finish the flooring up to the the door threshold. So there was, the tile were all like irregularly cut, and they didn't quite make it to the doorway. So yeah, I guess if your telepresence robot's going, across that, it might be a little rough, or in the corner of that room where the floor slants downward quite a bit,
So right there's that, but even just moving around, right? You get so many of the robots we build have the things on a mast of some kind.
Yeah.
And whenever it starts up and slows down, I mean, it's all jiggly.
Yeah, it's gonna whip around.
So anyhow,
yeah,
fun. Too many projects.
Most of the other places in the makerspace, the thing would go. You've got smooth transitions, smooth flooring. So I don't know, maybe the occasional mat or something, you have to get up on or something.
Or Dave stares at SMU.
Was it? Oh yeah. Well, there are a couple ramps, but I don't know if a telepresence robot would have those doors are pretty difficult to open. You'd have to have some force to open them. So if you wanted to venture outside, I guess.
I think if we have that drive plus video and take a robot, that's almost it, right?
Yeah. Chris seems pretty close.
Yeah. So yeah, if we can make that drive a little bit friendlier, like the UI a bit better.
Ray, we used to have this radio controlled car with a camera and transmitter on it. We drove around the building at SMU, and the camera's mounted on a gimbal, so we could look both ways before crossing, and you could also look up and down. And so that made it look extremely anthropomorphic. It could shake its head no, it could nod yes. So we found out that we didn't have to have the ability to open doors. You just roll up to a door and you wait there. And after a while, a human comes up and they'll look down and they'll say, do you want to go in? And you go, yeah. They'll open the door for you and let you in. My great fear was always that the last thing we would ever see would be a hand,
Oh, yeah.
Yeah.
Oh, that's good. Yeah, there was I think her last name is Margulies. The Good Wife. They tried using telepresence robots at the law firm, and I think this one woman had just had a child and didn't want to come in and wanted to spend some time with the child. But anyway, they had glass-walled conference rooms. So the thing would come up and just
I remember.
slam into the
that's like the that right, yeah, but that reminds me of this telemedicine. Like it's just a robot where the doctor or the nurse will push that platform somewhere and then the doctor will talk to a patient. But yeah, that reminds me of that that kind of instrument, which is kind of a teleconferencing tool. Plus some camera, high fidelity camera so that the doctor can see something clear.
Yep.
Yeah. So,
and I think one of the other things they did, they kind of got fed up with the robot and they just taped a piece of paper over the camera. So, it couldn't see and it was like, banging into walls. And
just abuse the robot. There we go.
Right, yeah.
David's had enough. Okay. Okay, guys. What do you think? Shall we break until next Tuesday? Sounds good. And I'll send something out for Thursday night. And David, if you're interested, I'll copy you and we can get you on that
and Carl,
email as well.
Carl, if you do that, can you add me to that?
Yeah.
Thank you.
Yep. And John K. I'll ask Mr. Doug. Yep.
Hey, Carl.
Yeah.
We got a Poke It update. Check your email, man.
Oh, yeah.
Yeah, we just got a Poke It email.
I haven't had a chance to read it yet. So
yeah, we're still not getting any yet, but they're closer.
That's good. Progress. Kickstarter. Yeah. They'll deliver.
I know they will.
2 others that I'm in won't deliver, but they'll deliver. Okay, guys.